Alright, we're talking section 5.4, exponential functions, and we'll get to the differentiation and integration because it's going to be so much fun because it's so easy. Alright, we'll talk first about the natural exponential function, which is f of x is equal to ln x. That's called the natural exponential function. I also have to talk about the inverse. And the inverse is equal to e to the x. So that should make sense. We've got y equaling e to the x if and only if x is equal to ln y. Alright, we also want to talk a little bit about this inverse relationship, and this is going to come in real handy. So jot this down, just a few notes here to get started. Natural log of e to the x is equal to x, and e to the ln x is equal to x. So we have that inverse relationship going on. Alright, let's look at a few problems that we're going to be looking at for tomorrow. Okay, so let's look at this equation to solve for x. Negative 6 plus 3e to the x equals 8. And I want to solve for x. So I want to isolate e to the x. So I'm going to add 6 and get 3e to the x equals 14. Divide by 3, and I get e to the x is equal to 14/3. Now how do I release that x out of that exponent? I'm going to take the natural log of both sides. When I take the natural log of both sides, I get x is equal to the natural log of 14/3. And I can put that on my calculator and approximate it. 3 decimal places gives me 1.540. Done. Let's look at another. Alright, natural log of 4x is equal to 1. So I'm going to what's called exponentiate each side. And exponentiate meaning make the equation that you see now an exponent. And I'm going to use base e because e and the ln are inverses of each other. So what happens when I exponentiate each side? Now I have 4x is equal to e. And I want to solve for x. X equals e divided by 4. And I want to approximate that, so I'm going to do this on my calculator. E divided by 4 is approximately 0.679. Done. Alright, we're going to take care of derivatives and integrals all in one swoop. So hold on, because this is going to be the most fun you've had all day. Derivative of e to the x. This is the one theorem that Mr. Claffey always remembers. This one and the integral. The derivative of e to the x is e to the x. Let's talk about it in terms of u, because now we're getting a little more complicated. The derivative of e to the u is e to the u du dx, or e to the u times u prime. Either way. So guess what? We're going to be doing all kinds of applications using the derivative. Now we have a new function. So let's talk about the integral. The integral of e to the x dx is equal to e to the x plus a constant. Doesn't get any better than this, guys. E to the u du. When I integrate e to the u du, what do I get? E to the u plus a constant. It's so simple that you're going to see when we do some problems, you're not going to believe that it's so simple. Alright, so I'm going to stop there, and we'll pick up with a couple of problems.